The sun, our closest star, holds a fascinating mystery, the coronal hole. Beneath the sun's brilliant burning surface, there exists a realm of darkness and coolness that contradicts what we know about this fiery giant. This phenomenon, my friends, is no ordinary feature of the sun. It's a coronal hole, a region in the sun's outermost layer, the corona that's not just darker, but also significantly cooler than its surrounding areas. Now you might wonder, how can a part of the sun known for its scorching heat and blinding light be cool and dark? Well, it's all about the sun's magnetic field. You see, the sun is like a giant magnet. In most areas, the magnetic field lines loop back onto the surface, but in coronal holes, they open out into space. This open configuration allows hot plasma to escape, which cools down these areas and gives them their dark appearance. But the intrigue doesn't stop there. These coronal holes are the birthplaces of something we call the solar wind. Imagine a gust of wind, but instead of air, it's made up of charged particles, constantly streaming out from the sun and hurtling through space at speeds of up to 1,000,000 miles per hour. Yeah, that's right, 1,000,000 miles an hour. This solar wind, born in the coronal holes, races out into the solar system, carrying with it the sun's magnetic field. So what we have here is a darker, cooler region in the sun's corona. A place where the sun's magnetic field opens up and lets out a stream of super-fast particles. It's a bit like the sun has these special doors that allow it to breathe out into the cosmos. And that's the beauty of science. It continually challenges and changes our understanding of the universe. The coronal hole, a darker, cooler region in the sun's corona, is a gateway for solar wind to escape into space. But what exactly is a coronal hole, and how does it form, you might wonder? Well, imagine the sun as a giant fiery ball of energy. It's covered in a blazing outer layer, a plasma soup known as the corona. But amidst this scorching surface, there are cooler, less dense areas. These are the coronal holes. Now don't let the term hole mislead you. It's not an actual hole or void in the sun. Instead, it's an area where the sun's magnetic field has opened up, creating a kind of cosmic gateway. This is where the magic happens, or rather, the science. The sun's magnetic field is like an intricate dance of energy, constantly moving and reshaping itself. When it opens up, it forms a corridor for the sun's superheated particles to escape. These particles charge with energy, then stream out into space, forming what we call the solar wind. Picture a teapot boiling on a stove. As the water inside gets hotter, it turns into steam, building up pressure. Eventually, the steam needs to escape, and it does so through the spout, releasing a gust of hot air. This is a pretty good analogy for what's happening with the coronal holes. The sun's energy builds up, and the coronal hole provides the escape route, like the spout on our teapot. But instead of a gust of hot air, we're talking about a stream of solar particles, whooshing out into the universe at incredible speeds. They race through space, taking with them a piece of our sun, and leaving behind a cooler, less dense area, the coronal hole. This process is fascinating, not only because of the stunning cosmic spectacle it creates, but also because it's a crucial part of the sun's life cycle. The sun, just like any living thing, needs a way to release its energy, to breathe out, if you will. In essence, coronal holes are the sun's exhaust system, expelling solar particles into the vast cosmos. These coronal holes and their solar winds have a greater impact than you might think. From the heart of these coronal holes, charged particles hurtle out, forming what we call the solar wind. Now, this wind doesn't blow like your typical earthbound breeze. Instead, it's a constant stream of plasma, or electrically charged gas, that travels at mind-boggling speeds, sometimes reaching up to a few million miles per hour. When this solar wind reaches Earth, it doesn't just disappear into the void. Instead, it interacts with our planet's magnetic field. This interaction can lead to the creation of geomagnetic storms. Picture this. You have a powerful stream of charged particles colliding with the magnetic field that surrounds our planet. This collision causes the magnetic field to fluctuate, creating these geomagnetic storms. These storms aren't just some exotic celestial phenomenon with no real-world implications. They can have a significant impact on our technology-dependent world. For example, they can disrupt communication systems, interfere with GPS signals, and even cause power outages. But it's not all doom and gloom. The interaction of the solar wind with Earth's magnetic field also creates one of the most beautiful spectacles in the natural world, auroras. These are the breathtaking light shows we often associate with the polar regions. The vibrant colors of the auroras are the result of the solar wind particles colliding with different gases in our atmosphere. Scientists keep a close eye on these coronal holes and the solar winds they produce. By monitoring these holes, they can predict solar wind activity and potentially mitigate some of the disruptive effects of geomagnetic storms. This is a perfect example of how understanding celestial phenomena can have practical implications for us here on Earth. So, these windows on the sun's surface can create a delightful light show on Earth, or potentially a technological nightmare. Interestingly, these coronal holes are not static. They follow a certain cycle. Now, this isn't some random celestial waltz. It's a carefully choreographed dance that's intrinsically tied to the sun's own rhythm, known as the solar cycle. Imagine the solar cycle as a great cosmic clock, ticking away every 11 years. During each cycle, the sun's magnetic field goes through a dramatic metamorphosis. It starts with a quiet period, known as solar minimum, where the sun's magnetic field is at its simplest. It's during this phase that coronal holes are more prevalent near the sun's poles. As the solar cycle progresses, the sun's magnetic field becomes more complex, and this is where the magic happens. The coronal holes start to decrease in size and number, only to reappear in larger numbers and sizes as the cycle nears its peak, or the solar maximum. Now you may be wondering, what's the link between the solar cycle and coronal holes? Well, it's all to do with the sun's magnetic field. You see, coronal holes are regions where the sun's magnetic field opens up and allows solar wind to escape. During solar minimum, the magnetic field is less complicated, so it's easier for these holes to form, especially near the poles. However, as the cycle advances towards solar maximum, the magnetic field becomes more tangled, making it harder for coronal holes to form. But as the magnetic field starts to simplify again, the coronal holes make their comeback, creating a fascinating pattern of ebb and flow. So, it's not just the Earth that has its seasons. Even our fiery sun has its cycles, and these cycles play a pivotal role in the life of coronal holes. It's a cosmic ballet, a dance of light and magnetism, choreographed by the laws of physics, and performed by the greatest star in our solar system. As the sun goes through its cycle, so do the coronal holes in a captivating cosmic dance. The sun's coronal hole is a captivating and crucial part of our star. It's an enigma that has sparked curiosity and investigation amongst astronomers and scientists alike. Let's take a moment to recap the key points of the intriguing phenomena we've explored today. Coronal holes are regions on the sun's outermost layer, the corona, that are cooler, less dense, and have open magnetic fields. This peculiarity allows solar particles to escape into space, creating what we know as the solar wind. These winds, while invisible to the naked eye, are a testament to the dynamic and complex nature of our sun. These holes are not static. They appear, change, and disappear in sync with the sun's 11-year solar cycle. During the peak of the cycle, the sun's magnetic field is the most distorted, leading to fewer coronal holes. Conversely, during the solar minimum, the field is less distorted and more coronal holes appear. The impact of these coronal holes extends far beyond the sun. The high-speed solar winds they generate can interact with Earth's magnetosphere, causing geomagnetic storms. These storms can lead to beautiful displays of auroras, but can also potentially disrupt satellite communications and power grids. Understanding the coronal holes, their formation, and their impact is not just an academic exercise. It has practical implications for our increasingly technology-dependent world. With better understanding and prediction of solar activities, we can take steps to protect our satellites, power systems, and other technological assets from solar storms. In essence, coronal holes serve as a reminder of the sun's dynamic nature and its profound influence on our planet. They are a testament to the sun's intricate and fascinating design, a celestial spectacle that continues to intrigue and challenge our understanding of the universe. So the next time you look up at the sun, remember the fascinating coronal holes, the sun's windows to the cosmos,